raised to the 1 times -2? -2, okay? And then we have x to the -2 raised to -2. So we multiply
4.
X to the +4, very good. And then we have y. What's my power on y?
Nothing.
1, right?
Oh, it's 1.
So then -2 times 1, -2. Are you following me? This is going to be on the next test, and we're getting harder and harder with these problems. -2 times 3, -6. Okay. Now let's go through, draw our fraction line, flip anything with a negative exponent. Does this have a negative exponent? Flip it down to the bottom. When we do, does it stay negative? It's positive, so we have 2 to the +2. X to the 4th, we're not going to flip that. We are going to flip this. It's going to be y to the +2 on bottom. This we're going to flip. It's going to be z to the +6. So I'm going to write this all pretty light. On top, we have an x to the 4th. That's the only thing left. What if we would have flipped everything? What would have been left on top, though? 1. Very good. So on top, we have x to the 4th. On bottom, we have 2 squared, which is 4. And then we have y squared, z to the 6. Now, z, y, x. Any like bases? Z, y, x. Are those like bases? No, so we're done. If any of those are the same base, we got to keep going. And then we'd be doing when you divide, you subtract. Does that make sense? Okay, so we're done. Are you guys getting more comfortable with properties of exponents? Okay, good. Very good. Okay, let's go. So today we're going to be graphing radical functions. We're going to be graphing square root functions and cube root functions. The good news is we graphed quadratics the other day, and that is a good introduction to this because it's pretty much the same thing, a little different, a few different things. So here's the parent function for a square root function. Remember, the 2, it's a square root because there's technically a 2 in there, but it goes without being said that there's a 2 there. So f of x is equal to the square root of x. This is what the function looks like. Now remember what a parabola looks like. It's like a U like this, right? Doesn't that look like a half of a U flipped on its side? That's because it is. Okay? They're inverses of each other. Oh yeah, you did. I'll get that in a second. Okay, and then cube root functions. Everybody look. Cube root functions. Notice we have this top thing that looks just like the square root, but then it curves down and goes back this way. That's just how cube root functions work. So parent function means the most basic non-shifted function, right? So if I say to you, what does parent function mean on the test, you'll know. The most basic non-shifted function. Okay, awesome. All right, so let's go ahead and write down how the shifts work. Well, the shifts work the same just like with every other graph. So looking at this, with square root functions, we have f of x is equal to a times the square root of x minus h plus k. So the x minus h, that's our shift left and right, just like with quadratics, just like with every other function we've dealt with. With our shift left and right, don't we always go opposite of the sign? Yes, right? That's the same with all functions. And then this added on the outside here is our shift up and down, and we always go with the sign, right? Are we all following? Now back to A. A is our acceleration. We are going to have an acceleration again. Now yesterday you learned that it's not an acceleration, it's a slope, right? With absolute value functions. But today we're back to accelerations. So we learned how to do accelerations with quadratics, but today we're just going to do the opposite. So you've got to just kind of memorize that. Since we're dealing with square root functions, you do the opposite of graphing a quadratic. So we're going to go up or down our a value, and then we always go over 1, 3, 5, 7. So remember the 1, 3, 5, 7 pattern was seen in quadratics. But remember with quadratics, we went always, no matter what, over 1, up 1, over 1, up 3, over 1, up 5, right? Or over 1, down 1, over 1, down 3, over 1, down 5. Now, with quadratics, we had to take the 1, 3, 5 and multiply by a, right? Now, with square roots, it's the opposite. You're always going to go up or down a. You'll go up if it's positive or down if it's negative. And no matter what, you go over 1, 3, 5, 7. So your 1, 3, 5, 7 will never change. Now, the reason it works exactly opposite of a quadratic is because square root functions are inverses of quadratics. So that's why they're exactly opposite. Once again, square root functions look like this. Okay. Then with cubic functions, cube root functions, sorry, not cubic, but cube root functions, once again, our acceleration works the same way. You'll go up or down your a value over 1, 3, 5. just like with square roots. But with cube roots, we go both ways. So we'll be going this way, and then we'll be going this way. Once again, what's added with the x under the cube root is our shift left and right. You always go the opposite. Our plus k's are shift up and down, and our sign will stay the same. We'll go with the sign. So really, I mean, not a whole lot of new, a little bit of new, but not a whole lot. So I'll give you a second to get that down, and then we'll just start practicing. It'll be more easy when we practice, I promise. All right, let's practice. Here we go. All right, so first of all, given this function, f of x is equal to the square root of x minus 2 minus 3. The first thing we always do is plot our starting point. That means, where are we shifting left and right? Where are we shifting up and down? So where's my shift left and right? Right 2, very good. We always go the opposite of the sign underneath, added with our x. So we're going right 2, and then what? Down 3. I like that you stayed with the sign on what's added on the outside, down 3. So our starting point is going to be over 2, negative 3. Did everybody get that part? Okay, right 2, down 1, 2, 3. There's our starting point. Now with square root functions, this is just something you're going to have memorized for the test. It works opposite of quadratics. You're going to go up or down your a value, depending if it's positive or negative. Well, what's my a value up here? 1. Positive 1. So we're going to go up 1. We go up our a value, and no matter what, you always go over 1, 3, 5 to the right. Okay? All right, so from the starting point, we're going up 1, up our a value, over 1. We just did that one, up 1 over 1. Now we're going to go up 1 over 3, up 1 over 1, 2, 3, and then up 1 over 5. Up 1 over 1, 2, 3, 4, and 5. And then we can go ahead and graph it. Questions on that? Okay, let's do another one. Now square root's only this top half. If this would have been a cube root, we would have also had to go down this way. We'll do an example like cube root in just a second. All right, questions on this? Let's do another one. Okay, given f of x is equal to negative 2 times the square root of x plus 7 plus 2. We're going to graph it. First things first, let's graph our starting point. Where's our shift left and right? Left 7. I like that you went the opposite. Left 7, and then left. Up 2. Our sign stays the same with what's ever added on the outside. So our starting point's at negative 7, 2. So I'm going back 7 and up 1, 2. There's my starting point. Is this a square root or cube root? Square root. Very good. So we always go up or down our a value. What's our a value in this one? Negative 2. So we're going to go down 2 and then always over 1, 3, 5, and then 7 if it fits. We'll only make you graph what fits. Okay? So here we go. Down 2 over 1, 3, 5, 7. So down 1, 2. We always work to the right. Over 1. So I just did that. Now I'm going to go down 2 over 3. Down 1, 2 over 1, 2, 3. And then we go down 1, 2 over 1, 2, 3, 4, 5. And then down 1, 2 over 7. 1, 2, 3, 4, 5, 6, and 7. All right, any questions? You'll notice that negative took it. It was like this, and it flipped it like this. Just like a smiley face on a parabola becomes a frowny face with the negative. Questions on that? Not too bad. Okay, let's do 2 cube root ones, and I'll let you practice on your own. Okay? So given f of x is equal to 1/2 times the cube root of x plus 2 minus 3. First, identify your shift left and right. Left 2. Very good. You go the opposite. And then what? Down 3. Very good. So we're going to go left 2, which means negative 2, comma, down 3, which means negative 3. So negative 2, negative 1, 2, 3. There's our starting point. Questions on how I did the starting point? Okay. Now this one's a cube root. We start through the top half just like a square root. Okay. Do the top half just like a square root. So you go up or down your a value. What's our a value? Positive 1/2. So we're going to be going up 1/2, and then over, so up 1/2, over 1, 3, 5, 7. So, for a cube root, the top half looks just like a square root. So we're going to go up 1/2, look, only going up 1/2, over 1. Then we're going up 1/2, and over what? Over 3. 1, 2, 3. Up 1/2, over what? 1, 2, 3, 4, 5. And that's all it's going to fit. Now, since it's a cube root, if you just stop here, you're going to get it wrong. That's a square root function. With cube root functions, you know it's going to come around and curve down and come back this way. So now you've got to go the other way. So we're going to go down 1/2 and over 1. Down 1/2 over 1, 2, 3. Down 1/2 over 1, 2, 3, 4, and 5. So it's going to come down and swoop around. Does that make sense? Somewhat. Yes? No? What? Okay, we're all good. Last one, then I'm going to let you work. F of x is equal to negative cube root of x plus 1. First of all, graph your starting point. Where am I shifting left and right? No, shift left and right. And then we're going what? Up 1. No shift left and right, up 1. There's our starting point. Then we know this is a cube root. We graph the top half just like a square root. We always go up or down your a value. What's my a value? Good. A is negative 1. So we're going to be going down 1, and then over 1, 3, 5. So down 1 over 1, down 1 over 1. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3, 4, 5. Now that's this part. Now we know that cube root functions swoop up and come around. They look like a snake, kind of. So we've got to make this look like a snake. So we've got to do the other side since it's a cube root. So since we went down 1 over 1, we're going to go up 1 over 1, up 1 over 1, 2, 3, up 1 over 1, 2, 3, 4, 5. Does everybody see how it looks like a snake? So if your cube roots don't look like a snake, you've done something wrong on one end or the other. Okay, are you all comfortable with square roots, cube roots? Not really hard. You do have to kind of memorize how to do it. Okay, awesome. Practice problems 1 through 6 and 11 through 13. Pay attention to square root versus cube root. I'll check them for you. We'll move on. So now, what we're going to do next is we're going to solve the square root function. Now, I need you to understand a few things. Okay? We're going to solve the square root function. Come back to me so we can get started. There's a couple different ways of solving square root functions or root functions. You can either do it by hand algebraically, or you can use your graphing calculator as well. So I'm going to show you how to use your graphing calculator. So get it out, turn it on. We're going to do this first problem together. So it says, solve the square root of x minus 3 plus 8 is equal to 12. Now notice, what we could do to solve for this algebraically is I would isolate the radical, so I would subtract 8 from both sides. Then I would get rid of the radical by squaring both sides and then solve for x piece by piece. We'll learn that a different day though. We're going to solve it by graphing. So looking at this, right here's a function. The square root of x minus 3 plus 8 is a function. And then 12 is technically a function. It's a straight line at 12. It's a straight line function. So you can graph it in your graphing calculator. In y1, you'll type in this, the square root of x minus 3, and then make sure you get out of the root plus 8. And then on y2, you'll graph 12. Now think about it, guys. If we have two functions, look up here. If we have two functions, and we graph a square root, this would be right 3 up 8, right? Right 3 up 8, so somewhere something that looks like this. And if we have a straight line at 12, at positive 12, where are they equal? It's at their what point? Their what? Intersection. I heard someone say it out there quietly. You're right. It's where they intersect. Where does this function equal this function? Well, it equals each other where they intersect. Does that make sense, everybody? So type into your calculator. in y, go to y equals. Yeah. So you have to go like this. Go y equals. You got to type them in differently. You can't do that. So you'll type in the square root. So second square, which would be put in square root. It was x minus 3, right? No, yeah. X minus 3. So x minus 3, close your parentheses, plus 8. That's our first function, right? Our second function, you'll graph in y2, is 12. Now you'll hit graph. Now your window might not be good. If you can't see where they intersect, you need to make your window bigger. Now look, I've fixed my window. I had to make it larger so I could see it. Does everybody see the root function? Not the prettiest picture because we've had to zoom out so far. And then right here, where that straight line is. So does everybody see it? So a window, my window's pretty big. I did x max to be 50. I did y max to be 50. Is everybody there now? Almost. Okay, almost. Now we want to know where they intersect, so you'll do second trace. So second trace, and then go down to intersect. So I hit enter. Now it says first curve. Now look up here in the corner. It's on the root function. It tells you right here, y1, it's on the first root, the square root of x minus 3 plus 8. So just hit enter. Now it says second curve. Make sure it's not on that same line, and it's not. It's on 12, so we're good. We don't even have to move our mouse thing. So we hit enter again. It says, do you want me to guess? Say enter. Our intersection is at x is equal to 19, y equal to 12, which makes sense. It's going to be as far up as 12 because the straight line was at 12. So our x value is what we were solving for. So x is equal to 19. Make sense? So x is equal to 19. If you plug in 19 minus 3, then if you plug in 19, you'll get the same answer. 19 minus 3 is the square root of 19 minus 3 is 16 plus 8. Square root of 16 is 4 plus 8, which is 12 is equal to 12. Does that make sense how you could check your answer? I plugged it back in. We got x equal to 19. 19 minus 3 is 16. So we have the square root of 16, which is 4. 4 plus 8 is 12. Does that make sense on how I checked it? Yeah? Are we all okay? Okay, that's how you solve by graphing. So do problems 7 through 9 go. Oh, one more thing. Look up here. What if I had this? I didn't say this, but listen, this is interesting. Everybody, you'll need to know this. What if I had two square root functions? Let's say I had the square root function right here, and let's say I had a square root function right here. Do they intersect? So what would the answer be? No solution. Okay, very good. Okay, guys, everybody look up here. So it says, right, because they don't intersect. So you got to look and use your knowledge. Okay. So did it say no solution? Okay, so there's a couple things. Look at number 9 on the worksheet. If it said no solution, just like it did with number 7, make your window bigger. Do it again, but you got to look with your eyes too and see, do they intersect? Are they going to intersect somewhere? Does that make sense? So on number 9, you can see that they're not going to intersect anywhere, right? Does that make sense? All right, so we're going to do number 14 together. So it says, rewrite the function in graphing form and describe the graph. So look at this. We have y is equal to the square root of 81x plus 162. So this one, what we're going to do is first check to see if there's something we can factor out of this. So y is equal to, so look underneath here. 81x plus 62. Let's ignore the square root for a second. 81x plus 62. We know how to factor. Let's factor out the greatest thing in common. There's something greater. There's something, the greatest thing that we can factor out is 81. So I'm going to factor out 81. Now I have to write what's left inside the parentheses. Now remember, if you factored out 81, you went back through, divide each term by what you factored out. Not subtract, divide. Okay, so now we're writing what's left inside our parentheses. 81x divided by 81.
1x plus 2.
X, good, 1, x, and then plus 162 divided by 81. 2. Does everybody get what I just did there? Now from here, check to see, does the square root of 81, what we have here is the square root of 81 times the square root of x plus 2. Does everybody see how 81 is just multiplied to x plus 2? So I can break it apart like this. Now on your calculator, do the square root of 81. You get a 9. 9 times the square root of x plus 2. Does everybody understand how 81 became 9? Okay, questions on that? I'm not done. Is that now in factor form? Easy, okay, to graph. Okay, so what's now you have to describe it. What's our shift, left or right?
Up 0 over 2.
Over which way?
Left.
Left 2. Very good. You go the opposite of what's underneath. So we're going left 2, and then we're going up or down 0. So no shift up or down, no up or down. Very good, Garrett. And then and then after that, if we were going to graph this, which we don't have to, but we would go up 9 over 135, right? So up 9 over 1, 3, 5. So in words, I want you to tell me what you do. Now keep in mind, guys, you go up 9 over 1, up 9 over 3, up 9 over 5. That's how we graph it. But I just want you to stay in words. Okay, questions on that? Okay, I'm going to do one more with you from the same worksheet, number 18. Here we go. So it says y is equal to negative cube root of 8x minus 56 plus 4. So look at number 18. All right, now notice this one's a cube root. Well, once again, we're going to go ahead and see if underneath the root something factors out. So we have y is equal to negative cube root of 8x plus 56. What factors out? An 8. Now what's left in the parentheses? X minus 7. Does everybody follow? And then we have the plus 4 added on the outside. So then we know we can take this and we can split it apart. So we have negative in front, negative cube root of 8 times the cube root of x minus 7. And then we still have our plus 4. So now take your calculator, take the cube root of 8, and you get 2. So we'll have negative 2, cube root of 8 becomes 2, and then we have times the cube root of x minus 7 plus 4. Do we have questions on how I did that? You have to pay attention. If you take a square root of 8, you're not going to get the right answer. It was a cube root. Does that make sense? Now in words, where's my shift, left or right? Right? What?
Right 9. I mean, right 7.
Right 7, then what?
Up
Up.
4. 5.
There's a 4 added on the outside.
Okay, then up 4.
Up 4. Does it make sense of why now?
Yeah.
Okay, and then we would go down 2 over 1, 3, 5, and it's a cube root, so we go both ways, right? That looks like a snake, right? Garrett, you promise you understand why when we add a 4 on the outside, that shifts it up 4?
Yeah, I got it.
Okay, awesome. All right, guys, so now you can finish the worksheets. And that's all we're learning today.